Welcome to Emelec Online Tutorial, and let us look at this question. And it reads that the third and the sixth term of an exponential sequence are 3 and 81 respectively, and we are told to find the fourth term. Okay, now let's start by saying that the nth term of any exponential sequence, or it can be called geometric sequence, is given as AR raised to n minus 1, okay, where a is the first term and r is the common ratio and n here is the number of what term. Okay, so we are told the third term equals 3 here, so we say t sub 3 now a, then r raised to the power of 3 minus 1. Okay, now this will give us t3 equals AR raised to 2, because 3 minus 1 is 2. Now, given that the third term equals 3, so we can just put this that equals 3, meaning T3 here equals what? 3. So let's make this equation 1. Now the second one, we plug in 6, okay? So here you have T6 equals AR raised to 6 minus 1. Okay, so here we have T6 equals AR raised to 5. Okay, and we are given that the sixth term equals 81. So this will give us what? 81. Then let's make this equation 2. So to this end now, since we have a common term here, take note the arithmetic operation between A and R is multiplication. So here we have A, we have A, R, R. So all we just need to do is to divide 2 by 1. So here we have AR raised to 5 equals 81. Then all over AR raised to 2 equals 3. Okay, so you can eliminate this. Now 3 here, 1, 3 here, that should give us 27. Now take note that according to the law of indices, if you have a raised to m all over a raised to n, as long as they are having the same base, this will give us a raised to m minus n. So applying that rule here, so here we have r raised to 5 minus 2, then equals 27. So here we have that r raised to 3 then equals 27. So in this case, what we just need to do is to cube root both sides of the equation. So here we have the cube root of r raised to 3 equals to the cube root of 27. Okay, in this case, this eliminates this, we are left with r. So in this case now, what is the cube root of 27? That should give us what? 3. This is not the final answer. We are told that to find a fourth term. Well, now since we've gotten the value of r, but we are yet to find the value of a, so what we just need to do is plug in the value of r in either of 1 or 2, so that we'll find the value of a. So I'll be making use of equation 1. So plugging in r equals 3 into equation 1. So here we have that a, then r raised to, that is replacing, okay, let me just put it this way. From equation, that will be 3 equals r raised to 2. Okay, so at this point, replace our r with 3. So here we have 3 equals a, then 3 raised to 2. This will give us 3 equals 9a, because 3 raised to 2 is 9. So let's divide both sides by 9. So this eliminates this 3 here, 1, 3 here, 3. So our a equals 1 over 3. So at this point now, we can now find the fourth term of the sequence. Using the same formula, we need to have that T4 then equals AR raised to n minus 1. So T4 here now gives us our a here is 1 over 3. you replace it 1 over 3, then times our r is giving us 3, then raised to 4 minus 1. So here we have T4 then equals, this will be 3 raised to 3. Now because 4 minus 1 will give us 3, and 3 times this one will give us what? I mean, the 3 raised to the power of 3 times 1 will give us 3 raised to 3. Now divide by what? 3. Okay, now since this is the same as 1, we can just write this, say, using this rule here, we have 3 raised to 3 minus 1, so give us what? 3 raised to 2, which will give us that T4 equals what? 9. Final answer. If you love what I've just done, please like, share, and don't forget to subscribe to my channel. Bye bye and remain blessed. Bye bye.